Let me introduce a topic for today. Today we'll see three topics, linear models, functions, and the quadratic equation or quadratic curve. Well, something about this. In the first lesson, at the end of the first lesson, we mentioned something about patterns of exponential growth and linear growth. And together with this, we talked about the opposite tendency, that is linear decay or exponential decay. Basically, two ways of interpreting growth and decay. Remember, we talked about, for example, when we talk about exponential growth, is a curve like this. This is, on the contrary, linear growth, something like this. Then you have exponential decay, something like this. And linear decay is this. Okay, so what can you appreciate? When we talk about linear models, actually, we want to interpret the relationship between two variables as a linear function, that is, as a straight line. Straight line, as we know, has an equation that can be written like this in a general form: y equals m times x plus b, where you know m is the slope and b is the y-intercept and so on, right? So this is what we've discussed previously. We will extend the concept of linear equations in general to other curves or equations that can be represented graphically in the coordinate plane. Curves that can be described like this, right? As some function of a variable. And we'll also talk about the quadratic equation. Well, so let's begin. Typically, when you see a linear model, right? For example, imagine this curve, y equals m times x plus b. In a linear model, what m represents the slope, right, is the amount or the quota by which the y variable grows when this grows in a unit. So when you interpret the terms of a linear equation, it means when x grows by 1, this means that y grows by m units, right? This is, remember the concept of the slope? We talk about coefficient or a quotient, right? Does anyone remember what is the slope defined as? This difference in y divided by a difference in x. What did we call this one? We call the rise. And this was the run. Okay, so if the run is 1, what is the rise? That's the concept. That's how we should interpret the parameters of a linear equation. And in a linear model, it's the same. For example, it says the value being dollars of a home from 2006 to 2015 can be estimated by the equation. Take a look at the equation. P equals 240,000. Take away 5,000 times T, where T is the number of years since 2006. So try to visualize in your mind when you see something like this linear pattern, this linear relationship. Try to visualize the variable on the left as your y and the variable on the right as your x. So in this case, our x is called t and our y is called v, because v is value, t is time. Okay? How do we visualize this? Immediately, remember that the coefficient multiplying our x, that is the slope. So if we see a negative slope, instantly, as we can see here, the negative 5,000, we can immediately perceive that this is a linear decay model. So if we can venture to advance, what is the likely description of this linear relationship on the plane. So it's something like this. Imagine something like this. Okay, where this is B, our Y, and this is the time. So we're basically talking about of a linear equation where the slope is negative, right? Because it reflects a descending tendency. Every time 1 year passes, our run here, if our run is 1, then the decay, or there'll be a decrease in the value of the home. That's the idea, right? What we call depreciation. Yes, that's exactly. The usual best value of a home is at the beginning when it's just built. Then year after year, as time passes, the value of the construction will be decreasing. That's normal, right? So it's a linear decay model. So if we are familiar with the terms of the linear equation with two variables, we understand the slope. We understand the y-intercept. Remember, this is the y-intercept. How can we interpret the y-intercept, that is a constant b, in a linear decay model? Well, you can understand that constant value as the initial value of variable y at, you know, at the beginning of the plotting of, you know, these values. That is to say, when x equals 0, that is the value of y initially. And it is this value here, okay? This is always b. So if we take a look, having this input, if we take a look at the equation, which of the following describes the meaning of the number 240,000 in the equation? The number 240,000, which would like correspond to our b here, what would that represent in this linear relationship between value and time? You have 4 answer choices. What do you say? Not so difficult, right? Remember, you can just write this in the same form as the model equation above. You would have b equals negative 5,000 t plus 240,000. So what is this? And what is this? They're asking us about this constant value, which is in the same position as our b. So what does that represent? The value of the home in 2006, the value of the home in 2015, or the other two options. Clearly, what we understand here, it must represent the initial value of the property, right? Yes, it's correct. Option A. Okay, so likewise, what does the other number represent in that equation? That is then the 5,000. Take a look. This is part 2 of the question. Which of the following best describes the meaning of the number 5,000 in the equation? Well, we having mentioned the interpretation of the linear equation with variables x and y, and what's the meaning of the slope, what's the meaning of the y-intercept, what should be the answer here? Okay, very good again. Okay, Lucian is right. The yearly decrease in the value of the home. Because think about this. If t is the number of years passed since 2006, so what happens when t is 1? That is 1 year later, what will be the value of the home, of the house? It will be, for example, for t equal 1, the value would be 240,000, take away 5,000 times 1. In other words, the new value will have decreased to $235,000. And if 1 more year passes, that is t equals 2, the value of the house will be decreased by $10,000 now. And so on. Every year, $5,000 fewer than the previous one, right? So it means a yearly decrease in the value of the home. Remember, in a linear model, the slope represents the yearly increase or decrease, right, not yearly, that is the unit increase or decrease when variable x changes its value by 1. This is the rule. When x increases or decreases, actually it's increase. Remember this. It's always increase because we're talking about around here. Okay, so we don't mean decrease. It's just increase. When x increases by 1, then y increases or decreases depending on the sign of the slope by the slope. M, which is the value of the slope. Okay, for example, if the slope is 2, that is to say, when x increases by 1, imagine that x is time. When 1 year passes, that means that the variable, depending on the time, this variable will increase by m units. But if m is negative, that means that when 1 year passes, for example, considering x is the time, then our variable depending on time, in this case, for example, the value of the home, will decrease by m because m is negative. Since here, our slope is negative, negative 5,000, it's a yearly decrease. Let's see some more examples. The maximum height of a plant h in inches can be determined by the equation h equals 4x plus 6 divided by 5, where x is the amount of fertilizer in grams used to grow the plant. Question 1. According to the equation, 1 more gram of fertilizer would increase the maximum height of a plant by how many inches? 1 more gram of fertilizer would increase the maximum height of a plant by how many inches? Okay, so it's similar. We have an equation that we can place in the standard form, which is this, right? Remember, y equals mx plus b. So if we assume that our y is called this time h, the height of the plant, then we can do this. We can say that h equals 4 over 5 times x plus 6 over 5. We simply split that sum as a sum of 2 fractions with the same denominator 5. Now we have this standard form in which we have clearly what is the slope and what is the y-intercept. Okay, in this case, our h-intercept. Okay, so having this form, so what would be the answer to this question? What would be the increase in height per every increase of 1 gram of fertilizer used to grow the plant? If you notice what we mentioned, like in the previous example, I think you can do this very easily. Remember the rule? When x increases by 1, then y increases exactly in the value of the slope, the value of m. Yeah, if m is negative, it means a decrease rather, right? But here we can perceive that since the slope is positive, we have actually a positive response. So what would it be? Since they're asking me exactly what would be the maximum height of a plant, not the maximum height, what would be the increase, right? Increase by how many inches? Okay, what did we say? When x increases 1, what happens with y? You can do this in a simple way. You can say, for example, what happens when x is 0? When x is 0, the y would be exactly b. And when x increases by 1, that is when x is 1, y will be mx or m times 1 plus b. So what would be the increase? Exactly this value, the slope. So if we take a look at the equation of the line, we see that the slope is 4/5. So what does this value represent? It represents the per unit increase of height regarding the quantity of fertilizer used. Since we're considering 1 more gram of fertilizer, okay, 1 more gram corresponds to exactly an increase of 4/5 inches. And that's the answer, because that's exactly the value of the slope. All we needed to do in order to find the value of the slope, which is the answer to the question, remember this value here, is simply take the equation originally and give it this form. Remember that we need to isolate the dependent variable, y or h in this case, on the left, and on the right, you should have this form. Coefficient times x plus a constant value, okay? And focus only on this value in the end. Okay, so let's see one more example. Okay, with the same relationship, linear relationship between height and fertilizer, amount of fertilizer. To raise the maximum height of a plant by exactly 1 inch, how many more grams of fertilizer should be used in growing the plant? So this is interesting. A moment ago, we set the equation of h in terms of x in this form. So how do we interpret this? That if you use x grams of fertilizer, you get a height of 4/5 times x plus 6/5. That's the height of the plant. So if we want to increase by 1 the height, right? What's the increase in x? So if h increases to h plus 1, what would be the increase in x? X plus, let's say, q. What is the value of this q? Can we do that? We can do it algebraically. We can do it numerically, which is faster. Just imagine this. What would be, let's say that we have the initial value of fertilizer. You can say, for example, it is 1, okay? Let's say, what is the height for an x value of 1? H of x equal to 1. It would be, according to the equation, 4/5 times 1 plus 6/5. Okay, good. This is 10/5 or just 2. 2 inches. Okay, I want to increase now the height 1 more inch, according to the statement. So since I want to have 1 more inch of height, that is to say, I want to increase this to 3, right? So 2 plus 1 equals 3. So what would be the value of x? When h equals 3, what is the value of x? This value of x taken away with 1 will give us exactly the value we're looking for. Let's do it like this. So if h equals 3, according to the equation, you would have 4/5 x plus 6/5. If you isolate here, you can multiply both sides by 5 to eliminate the denominator. You have 15 for x plus 6. So from this, you have that for x equals 9. And finally, what we have here is x equals 9/4. So what is this? That if you want to go from a height for the plant of 2 inches to 3 inches, that is exactly increasing 1 inch, how much more fertilizer you have to use. Originally, for this height of 2, what we use of fertilizer was 1 gram. But for a height 1 inch higher, the amount of fertilizer is 9/4. So what is this increase? What is our delta in the amount of fertilizer? The difference, right? 9/4, take away 1, that value is exactly 5/4. And that's the answer to the question. That is 5/4 grams of fertilizer. Now, there is a much faster way to solve this question. Take a look. How can you visualize this? This is exactly the same as finding the slope, that is this ratio of rise over run, but in the reverse relationship. So if you say, if h is 4/5x plus 6/5, but what is x in terms of h? If you just isolate in this equation the value of x rather than h, so what you would have is this 5, okay, let me write it over here. You would have 5h equal to 4x plus 6. You have 5h take away 6 equal to 4x. Then isolate x and you have x equals 5/4h take away 6/4. Focus on this. This is the slope for the linear relationship between h and x. Now x has the dependent variable. So this slope is exactly the answer to the question. Every time you increase h by 1, you will have x increase by 5/4 grams. Okay? Now, an even faster way to solve this type of question would be what? Once you have isolated the slope in the original equation, that is this value here, if they ask you, okay, if I increase 1 gram of fertilizer, what is the increase in the height? The answer is the slope. But if they ask you, if I increase the height in 1 unit, what is the increase in the amount of fertilizer? That is in the independent variable. Simply take the inverse of the slope, 4/5, reverse it or invert it, and you have 5/4. And that's the answer. So it's just a matter of remembering how these linear relationship variables work. Okay? So far, any questions, any doubts about this? Let's see some more examples. Take a look at this one. T equals 65 minus 6 times n. A can of soda is put into a freezer. The temperature T of the soda in degrees Fahrenheit can be found by using the equation above, where m is the number of minutes the can has been in the freezer. What is the decrease in the temperature of the soda in degrees Fahrenheit for every 5 minutes the can is left in the freezer? So that's it. We have a linear model, right, between time and temperature for the soda, and we need to answer the question. Okay, I'll just stop a moment here so that you can try to solve it on your own. What you think is the answer? Okay, this is a tricky question. If you understood how to interpret linear models so far, then you can see that what this represents, this constant here, the slope, right? The slope of the line, because this is like a linear relationship, something like this. This is T, temperature. This is M, minutes or time. So this value here is 65, which means at time 0, where n minutes, 0 minutes have passed, the moment you put the soda in the refrigerator, in the freezer. At that moment, the temperature was originally 65 degrees. That's what the 65 represents. And what does the -6 represent? Is the decrease in degrees in temperature for every minute, right? That's what we said. We established this rule or law, if you want. When M increases by 1 unit, then T, in this case, because it is a slope, a negative slope, T decreases by 6 degrees. So if in 1 minute, the decrease is 6 degrees, in 5 minutes, right? The decrease will be 5 times 6. In other words, 30 degrees. 30 degrees Fahrenheit. That's the answer to the question. That's the decrease. Be careful not to confuse the question with what would be the new temperature. No, that's not the answer. It's how many degrees would the temperature decrease, okay? So that's actually the number of degrees you are subtracting from the original 65 degrees. Of course, if you subtract 65, take away 30, you will get, let's say, something like this. Let's imagine that when 5 minutes have passed, okay, what is the value of this? It would be actually 35 degrees. Okay, that's the idea. That's the understanding of this question. But the decrease in temperature is this. The delta of temperature, okay, or how much temperature would be decreasing. Well then, let's move on to another question. Well, and those were the examples related to linear models. Now we talk about functions and how to interpret functions on XY plane, okay? When we talk about functions, it's interesting because a function actually you can interpret as a machine, right? A machine is something like this. Imagine that you have somewhere where you have inputs ingressing to the machine, and you have some outlet where the outputs are coming out of this machine. And what is the machine? The machine represents a set of operations over an independent variable X. And we represent this set of operation as an algebraic rule. For example, here, you can see this rule in terms of X with a series of operations done over the variable. For example, square X and then add 1. So if you consider that this is the function, the definition of the function, in a notation like this, you know, the letter, which is the name of the function, it could be F, G, or any other name, perhaps, usually short words only. What does F of X represent? This expression F, the parentheses, and then the independent variable. Well, this actually represents the output of the function, while X is always the input. And whatever, you know, X is just a placeholder variable. Whatever you put in the place of X instead of X, that's your input. For example, if I have this definition, F of X equals X squared plus 1, I can say that my input could be anything. For example, if my input is 2X, wherever X appears, I will replace for 2X. Why not? X is any other letter, or is the same as any other letter. So F of 2X, according to this definition of X, would have to be 2X up to 2 plus 1. So if the input is 2X, this is the input, the output is this whole expression. You can see here the output for the first input. 2X, square that 2X, And you know this, if you do it, if you develop the parentheses, you have 4x squared plus 1, okay? Now, what if the input were this, b plus 1? So if you place b plus 1 where the input goes, then you replace b plus 1 wherever the placeholder variable x appeared originally. So you would have b plus 1 squared plus 1. And of course, if you develop that, you obtain another expression. You can break the parentheses or just leave it like that. But this expression represents the output when the input is b plus 1. This is the second output. And let's say that the input, it's panda. You know, if the input is some variable or some constant value called panda, then what is f of panda? It's simply panda, whatever panda means, a constant or variable, squared plus 1. So this expression represents the output that the function machine, you know, yields when you give that input panda. So simply the variable x that we define here, it's simply a placeholder. It represents the input, and the set of operations applied over x represents the output. So that means that when you have, for example, something like this, take a look at example 1. If there is this definition, this rule f set up as this sequence of operations with x plus 1, and that sum up to exponent x. So how do we process this? What is the value of this sum? F of 0 plus f of 1 plus f of 2 plus f of 3. Can you try? What would be the answer to this question? What you can do in order to find out is, first, find the output for the function f when you give the input 0. Then find the output when the input is 1. Find the output when the input is 2. Find the output when the input is 3. And then add up all those 4 outputs. And that's the answer. Example, what would f of 0 represent? It represents the value, the output value of this expression when you replace 0 where x originally was. So it would be 0 plus 1 up to 0. In other words, 1 up to 0 or simply 1. This is the value of f of 0, 1. So likewise, what would be f of 1? Any idea? Just follow the rule. 1 plus 1 up to 1. So you have 2, the sum in the parentheses, plus up to 1. Simply 2. And so on, right? Yeah, what happens when you have f of 2? F of 2 would be 2 plus 1 up to 2. So this is 3 squared or 9. And finally, f of 3 equals 3 plus 1 up to 3 or 4 cubed, which is actually 64. Okay, what is the answer to the question then? Is the sum 1 plus 2 plus 9 plus 64? In other words, 76. The sum of the 4 values. All right, so that is the way you work with functions and expressions with functions. Let's see example 2. What does it mean when a function is defined or not defined? That a function is defined means that the output value exists. Now, it is true that for most values in this example, in example 1, whatever the value of x is, you can always expect a certain output. But what if, for example, you had a function like this, g of x equals 1 over x minus 5. Do you think it's possible to find this output, g of 5? Can we? What is the value of that? Or it doesn't exist, and why? Remember, your participation is welcome, class, and it means something. Okay, think about this. Take a look. If I substitute 5 where x goes, what do I obtain? 1 over 5 minus 5. That would be 1 over 0. But people, is it possible to divide by 0? The division by 0 doesn't exist in real numbers. So we don't know what to say. G over 5 is simply not defined because the definition of the division by 0 is still open. Nobody has defined what is the result of dividing a number by 0. So because of that, we say that function g is not defined for the value of x equal to 5. Now, likewise, for which value of x in this definition of the function f, the value of the function f would be undefined. Since this function has the form of a fraction, and we know that fractions are not defined if the denominator is 0, so this is another way to ask whether there is some value for x that makes this denominator 0, in which case, well, the function wouldn't be defined. Because for the value of x that precisely makes the denominator 0, that value doesn't exist, right? 4 divided by 0 doesn't exist. So which value of x makes the denominator 0? Actually, the value of 5. Very good, Luciana. So you see, if x squared minus 10x plus 25 equals 0, this one is the square trinomial, right? So this is x minus 5 squared. So this means that when x equals 5, this denominator will be 0, and therefore the function f will not be defined. So the answer is this. All right, let's see another example. If f of x minus 1 equals 6 times x, and g of x equals x plus 3, what is the value of f of g of 2? Now, this is what we call composition of functions. What is a composition of functions? Is having as the input for one function, the output of another function. Because what is the input of f here? Is this. What is inside a parenthesis corresponding to f. And since this is the input of f, we need to first know what is this expression in the input value. And that is g of 2, which is the output of function g when the input of g is 2. So for finding g of 2, what we do is this. Substitute 2 where x goes and say this is 2 plus 3. In other words, 5. So now the expression, the original expression in the question would be f of g of 2. But what is g of 2? G of 2 equals 5. So now this expression, f of g of 2, would be actually f of 5. Because g of 2 equals 5. See? Okay. If g of 2 equals 5, okay, and we have to find what is f of 5. Think about it. What should be the value of x according to the definition of function f? What should be the value of x for this to take the input value of 5? Which value of x matches this input of 5? Clearly, the value of x that matches, the input value of 5, it should be 6 because f of 6 minus 1 is the same as f of 5. But according to the definition for function f, take a look. What happens when you have f of x minus 1? The value of that output would be 6 times x. In other words, this expression equals 6 times 6. And what is this? This is 36. So the answer to the question is 36. Well, that is another example where you have to deal with composition of functions. But questions about composite functions can be tricky. This is just one simple example. What about this one? Take a look at this. Functions f and g are defined by f of x equals x plus 1 and g of x equals x over 2. If f of g of f of k equals 10, what is the value of k? Now, you can do things in this way. You can go to the innermost function call or output expression. The innermost would be f of k. Let's try to figure out what f of k is in terms of the definition of the function f. So if I proceed to calculate f of k, what would it be? F of k would be, according to the definition, the output of f when the input is x is the input plus 1. So if the input is k, my output will be the input k plus 1. That's it. So now I can do one replacement. The original expression would be f of g of, instead of f of k, I will place k plus 1. And this will equal 10. So what about this one here? Let's change colors. This part. G of k plus 1. If we apply the definition on this particular input for the function g, let's remember the function machine, okay? Whatever the input is, just substitute where the placeholder variable appears. So what is the definition of g is this. This is the input. So whatever the input is, the output is the input divided by 2. As simple as that. So what would be the value of g of k plus 1? Okay, take the input, k plus 1, and divide it by 2. That's the value of the output. K plus 1 over 2 is the value of g of k plus 1. So now another substitution. If we do the second substitution, the original expression would therefore be f of, what is g of k plus 1 is this. So f of k plus 1 over 2 equals 10. Now, what is the last step? We know how to evaluate function f. If we know the input, and this is the input, what is the output? Simply take the input and add 1 to it. That is the definition of function f. So let's change colors one more time. What would be then f of k plus 1 over 2? According to the definition for function f, just take the input, k plus 1 over 2, and add 1 to it. And this will be the output of f when the input is k plus 1 over 2. So what is this? Okay, you can give a common denominator, right? It's k plus 1 plus 2 over 2, which is the same as saying k plus 3 over 2. That's it. That's the value of f of k plus 1 over 2. So the original expression where you have f of g of f of k equals 10 simply means that this whole expression in terms of k is k plus 3 over 2. And this equals 10. So from this, you can calculate k. K plus 3 equals 20, and k equals 17. The answer to the question. All right. Remember that in some questions in the SAT, you will have to input or digit the number. In this case, you would have to digit 17. Okay. Let's see some more examples or some considerations to work with functions. Remember that when you graph functions, because a function is a rule in terms of the independent variable x, so in order to graph a function, you can consider that the value of f, or that is the output of the function, is the same as saying the value of y on an xy plane. So for example, when you see this curve, y equals x squared plus 1, this is exactly the same as if you saw written f of x equals x squared plus 1. Okay, so if you have a graphing question, and in this question they mention f of x, simply think about f of x as the variable y, the dependent variable. And since y will be f of x, now when you see the coordinate plane where to graph a function, this is the independent variable x, this is the dependent variable y, or you can say that in the vertical axis, you can have the values of f of x. So imagine that you have a curve like this. What does this curve means? Every point on this curve has two coordinates. Say, for example, here. This coordinate means the x value, and this one is y or f of x. So actually, the pair of coordinates that describes the position of the point in the coordinate plane is actually the input and the output of a function. You can interpret like that, okay? A graph of a function f of x, or a g of x, or any other name, but usually in SAT questions is f of x, okay? The points give you the inputs and outputs of the function. So let's see some examples. Imagine that they present you with this coordinate plane, okay, where you have your vertical axis, your horizontal axis. What have we learned about y? That we can consider that y, this is the same as f of x. Okay, f of x. In other words, any point on this curve, any point, for example, this point, represents with its coordinates, one is the value of x, the other is the value of f of x, the output of the function, okay? So here they tell you the graph of f of x is shown in the xy plane above. For what value of x is f of x at its maximum? In other words, what is the point in this curve that has the greatest possible value for the output, for f of x or for y? Clearly, you see that it looks like an histogram, right? This point, then it goes down, goes up, then keeps the same, goes up again, and then goes down and never goes up again. So what is the point that has the greatest possible value for y? Clearly, is this one. That has a value that is at the top of the curve. Vertically speaking, right? The vertical coordinate here is the top value for f. And this top value, to which value of x, that is the horizontal position on the x-axis, corresponds? Well, if each of the boxes in the quadricle is 1, then we have 2, 3, 4, 5, and this would be 6, right? Okay, no, here, 5. 6 doesn't correspond to the maximum. So you can see clearly that when x equals 5, Okay. Just give me a moment, please. Apparently, this window froze. All right. Now it returned the possibility to draw here. Okay, this one, right? This is the maximum and corresponds to the value of x. And of course, f of x at its maximum would be 5, right? But the answer to the question here is, no, sorry, it would be 4 here. The answer to the question is 5. Let's see another example. If the function with equation y equals ax squared plus 3 crosses the point 1, 2, what is the value of a? Beware of questions where they tell you that a function crosses or passes or contains a certain point. When they tell you that a function crosses, contains, or passes through a certain point, that means that the point given must actually belong to the curve of the function. And what does that mean, analytically speaking? It means that the coordinates of this point will make the equation of the function true. In other words, if it says that the function crosses the point, that means that this point belongs to the function. So if it belongs, if I substitute the coordinates precisely where x and y go, it produces a true equation. So let's do that. 2 where y goes. Okay, so 2 equals a times x squared, that is 1 squared, plus 3. And this is a true equality or a true equation. Why is it a true equation? Because the point belongs to the function and the coordinates of the point must satisfy the equation of the function. Same as when a point belongs to a straight line, the coordinates of the point must satisfy or make the equation of the line true, right? It's exactly the same concept. So take a look. What happens here if I have an equality, a linear equality with a as my unknown? I can easily isolate a. 2 equals a plus 3. So what is a? A equals 2, take away 3, negative 1. And that's the answer to the question. So this concept repeats over and over. Please be always on the watch for expression like crosses, passes, or contains. Any of these verbs indicates that if you substitute the coordinates of this point in the equation, there is a true equality as a result. Another example. If the function y equals x squared plus 2x minus 4 contains the point m, 2m, and m is greater than 0, what is the value of m? Okay, you can try. You can try for a moment. Okay, so let's continue. They tell you that the function contains a point. So what did we say? We say that if we substitute the coordinates of this point in the equation must be true. So let's do that. Here, y corresponds to this value, the output, that is f of x, 2m equals x squared. Okay, the value of x is m. So m squared plus 2m, take away 4. We can notice instantly that these two terms can be canceled since this is a true equality. Okay, so what we have is 0 equal m squared, take away 4, or m squared equals 4. We know that possible values of m in this equality would be 2 or negative 2. But since they give me the restriction that n must be positive, clearly the only value of m that satisfies this equality is positive 2. So our answer. Well, let's continue. There is a concept where they tell you that a function has zeros or roots or x-intercepts. Okay, when they mention the expression zero or root or x-intercept, refers to the value of x that, make the value of the output of y or f of x equal to 0. So the value of x that makes this true is called a zero, a root, or an x-intercept. For example, when we talk about a straight line, what is the x-intercept? Is this value of x. Also, it's called a zero. If we talk about a quadratic equation, for example, let's talk about the quadratic curve, which is the parabola, right? Imagine we have this parabola. So what are the zeros or roots or x-intercepts? They are the values, this and this, x1 and x2. These are the zeros of the quadratic equation, which is exactly what happens when you have the quadratic curve a sx squared plus bx plus c equal to 0, right? When you solve this, what are you doing? You're solving a quadratic equation with one variable, but you are making the value of y 0 in order to make this happen. Okay, so the values of x where the function crosses the x-axis. And if we talk about any other curve, not a quadratic or a linear equation, perhaps something like this. Imagine this. We have f of x and we have x. Imagine that we have something like this. If we have this curve, what would be the zeros of this function? It would be this value, this value, this value, this value, and this value. All values of x where the value of y is 0, or where the curve crosses the horizontal axis. But actually, this comes from a concept which is actually wider or broader. How do we understand this? They tell me, okay, I have a curve that is this, f of x, and I have another curve that is g of x. How do I find the points that are common to these two curves, or the points where the two curves cross? Imagine you have, okay, on the vertical axis, this curve that we call f of x. And we have another curve, g of x. This is f, and we have g of x. How do we solve the value of this point, or the coordinates of this common point or the intersection of the two curves? Easy. We solve this as if we have simultaneous equations, because if we have that on one hand, f of x is equal, y equals to some expression in terms of x, and g, we have y equal to some other expression in terms of x. So to find the coordinates of this solution, we can simply do this, equal the two equations that define f and g. The values of x that make this true are the solution to this intercept or intersection point of the two curves. Another common situation is where they ask you, find the intersections of a curve f and a horizontal line which has an equation y equals k. If they tell you, what are the solutions of, f of x and y equal k, they are simply telling you to find what are all the points where this curve x, for example, let's say this, crosses a horizontal line that passes or has as a y-intercept the value of k. Imagine this is the value of k. So there is a horizontal line crossing. What would be the crossing point of the curve f and this horizontal line? It would be this, right? And it is possible that the curve and the line may have more than one intersection. Imagine having this. Imagine that you have this f of x here, and we have this horizontal line. How many intersections do you find between this horizontal line y equal k, k is a constant value, and the curve f of x? How many intersections do you see in the picture? Let's count them. 1, 2, 3, 4, 5. Yes. How do we solve this analytically? When they give you the equation for f of x and they give you y equal k, simply do this. Equal the expression for f of x to k. Solve for x and you'll find all the possible solutions. Okay, so that's a way you have to interpret questions where they mention these kind of intercepts or crossing points. Let's take a look at an example. The graph of f of x equals, okay, it's a cubic function, x cubed, take away 2x squared minus 5x plus 6 is shown in the xy plane above. How many distinct zeros does the function f have? In other words, remember the expression zeros means how many crossing points exist between the curve f and the horizontal line y equals 0. Y equals 0 is actually this, right? The x-axis is the same as the horizontal line y equals 0. So how many crossing points do you see there? Easy, right? Yeah. Here is one, a second, and a third. So the answer to this question is there are 3 distinct zeros for the function f. What are their values actually? Okay, if we assume that each of the boxes in the quadricle corresponds, each division of the line is 1 unit, you could say that this is for 1, 3, and -2, perhaps, okay? But here is the concept that you need to catch, okay? How many distinct zeros, how many x-intercepts? You can read this zero, this word zero, also as x-intercepts. Well, there is a second part to this question. The same graph, the question says, if k is a constant such as f of x equals k has one solution, which of the following could be the value of k? How do we interpret this question? Remember what I told you? If they tell you that there is a graph of a function and they tell you solve what is the solution for f of x equals k, f of x equals k means find the number of intersections, okay? The number of intersections between the function f and the line y equals k. But since they already tell you that for a certain value of k, this problem has only one solution, it means that the position of k must be such that when you count the intersection points between the horizontal line y equal k and the curve, there is only one possible intersection. Example, imagine that this is one possibility. if I have this as my y equal k, this is my y equal k horizontal line, clearly this line intersected with the curve of function f would only have this solution, right? This would be the only intersection point. Another possibility is, for example, here. This is another example of another line y equal k. When I solve the problem f of x equals k, this will also yield me just one solution, this. This will be the crossing point between these two lines. I will find the value of x for this intersection point by solving this equation, f of x equals k. So, since they give you 4 alternatives, which of the 4 alternatives looks like the green or the blue line, would you say? Let's take a look at one at a time. Could it be y equal to -3 or f of x equal to -3? Where is -3? Take a look. If this is 2, clearly this is 1, and this is -1, and this is -2, and this is -3 here. So does a line, passing on that vertical position intercept the curve f in just one place? That would be the meaning of saying one solution. No, it intersects the curve in 3 different places. So we can cross out this one. What about k equal 1? Is that possible? K equal 1 is over here. Again, we have 3 solutions, not just one. Cross out this one. What about k equal 5? 5 is here. Take a look at this. This is the passing point for the line. Again, we see 3 different solutions, not just one. So we have already crossed out 3 options. The correct one must be the last. 9. And we can verify that that is actually correct. Take a look. Why? Because simply like this, this is 4. So this is 5, 6, 7, 8, 9. Clearly, if this is the position of 9, a line crossing the vertical axis in that position, when you solve f of x equals 9, you will have only this intersection point. So that is why this is the correct answer choice. Okay, let's see now one last example. Which of the following could be the graph of y equals x cubed plus 2x squared plus x plus 1? You don't actually need to know what the real cubic function looks like in order to solve this one. It's just a matter of being a little creative. Do you know what represents the intersection point of the curve and the vertical axis? For example, in this graph, this point, this point, this point, and this point correspondingly, what do they represent? They represent the value, okay, in this point, it has 2 coordinates. The horizontal coordinate is always 0, and the vertical coordinate is the corresponding value of y when x is 0. So what happens when in this equation, you change x for 0? Change x for 0, y equals 0 cubed plus 2, 0 cubed plus 0 plus 1. So it yields 1. Clearly, whatever the form of the function, this curve must cross the vertical axis exactly in point 1. That is in the upper or positive part of the y-axis, not below 0, but above 0. You see, this one cannot be, I mean option A, because it crosses on the negative part of the y-axis. This one crosses on the positive part of the y-axis. So it is a potential, but clearly, if this is possibly true, then it must be true because in the SAT, only one option can be true or correct. Here it crosses on 0 exactly, and here it crosses on a negative vertical position. So crossed out the 3 choices that are incorrect, and we keep this one. B is the correct choice. So now it's time to study the quadratic function in more depth. The questions about the quadratic function in the SAT can be pretty complex, but you need to be familiar with a number. It's actually a bunch of concepts that help you describe completely the quadratic function in the plane. So let's talk about the quadratic function. A quadratic function always has this form. F of x equals ax squared plus bx plus c. Remember that this can also be y, okay? It's the same. What is a quadratic function in the xy plane, actually? Well, this form of the function is always a parabola. A parabola is this curve with a U shape, right? Something like this. With the 2 arms of the curve opening either up to the infinite or down to the infinite. So you can have the curve like this. For example, this is the y-axis, this is the x-axis, okay? It could be a U shape oriented upwards, and there is here like a lowest point, which is called a vertex. And you can also have this. Another possibility is that you have something like this. Okay, imagine here we have the XY plane. Okay, so in both cases, it's a U shape, either with the arms upside or the arms downside. So basically, the value of this constant with the sign indicates the orientation upwards or downwards. When A is positive, it must be a shape like this. When A is negative, it must be a shape like this. Now, there are other relationships, okay? Other relationships important to understand between A, B, and C, these constant values. For example, the value of C is exactly the value where the parabola cuts or intercepts the vertical axis. For example, imagine this. Imagine something like this. If you have this parabola, this point here exactly has as vertical coordinate the value of C, always, okay? Now, what other relationships exist? Let's see several examples with different forms of the quadratic curve, and we'll discuss important information about this function. Okay, let's say, for example, that we have the quadratic equation f of x equals x squared minus 4x minus 21. So how do we calculate the roots? Remember that we've already said that the roots or the x-intercepts or the zeros are the solutions of the equation of the form f of x equals 0. So if we equate the equation to 0, and we, for example, factor, you can factor like this, right? X plus 3 times x minus 7. Negative 7 plus 3 equals negative 4. 3 times negative 7 equals negative 21. So this is a correct factorization, and from equating each of the factors to 0, you get the 2 solutions, the 2 roots. How do we calculate the sum and the product of the roots? There are questions in the SAT where you actually need to not to calculate the roots, but just directly the sum and the product. And you can do that very fast if you just remember these two formulas. Okay, remember that A is the coefficient that multiplies the quadratic term, B is the coefficient that multiplies X, and C is the constant value. So, considering that that is the meaning of A, B, and C, the sum of the two roots of the equation is this expression, negative B over A. Of course, we can verify that, right? If we add negative 3 plus 7, what happens? Negative 3 plus 7 equals 4, positive 4. Okay, what is negative B? Negative B is here, this value with the inverse additive, because negative 4 is B. So negative B should be negative 4. And this divided by A, which is 1, gives you exactly 4. So, correct prediction. The product of the two solutions is always the quotient C over A. So C over A is what? Negative 21 is the value of C here. Divide by 1 and you get negative 21. Can you see that the product of negative 3 and 7 is actually negative 21, right? What is the vertex? Remember that a vertex is this extreme point. The point in the U shape, when the U shape is, oriented upwards, then the vertex is the point with the least possible value for Y, okay? With the lowest value of Y, this is the minimum Y here. Okay, that point is the vertex. And how, since the vertex is located symmetrically in the vertical parabola, you can simply obtain the vertex, the coordinates of the vertex by doing this. The horizontal coordinate of the vertex we call H. And this you obtain using this formula. Simply take the average of the two roots. Okay, let's do this. For example, negative 3 plus 7 over 2. We have negative or 4 over 2 that equals 2. So this here should actually be 2. And what is the vertical position of the vertex? Well, if you want the vertical position of the vertex, is simply replace H in the equation and calculate the value of F. That is the vertical position. So here, for example, if we substitute 2 where X goes, 2 squared minus 4 times 2 minus 21, this is 4 minus 8 minus 21. Negative 29 plus 4 equals negative 25. And that is, this value here would actually be negative 25. Okay? So that's the way you calculate the vertex. There are some questions that ask you to calculate the vertex of a parabola. There is something called the vertex form of the equation. The vertex form of the equation comes actually from the concept of the vertex. The vertex form is very useful in some questions, and actually you can form the vertex form of the equation if you know the vertex directly. If you have already solved the equation, found x1, x2, the vertex, then just using the coordinates of the vertex, you can state the vertex form of the equation following this pattern. A multiplies the square of a binomial, which is x minus the horizontal coordinate of the vertex h, and then that expression plus the vertical coordinate of the expression. We just said that in this case, the vertex was 2, negative 25. So if we use these two values, we can form the equation directly. A equals 1 in the original function f. So it's 1 times x minus 2 squared, take away 25. Or plus negative 25. Okay, so this would be the vertex form. Now, what happens if you want to obtain the vertex form and you don't have the vertex already? Because if you have the vertex, you simply replace the values of h and k here, and you obtain the desired form of the equation. But how can you build the vertex form directly from the equation without solving actually the roots x1 and x2? Let's see some examples of this. Okay, we'll see that in a moment. But now we'll talk about the discriminant. What is the discriminant? Well, the discriminant is one expression that appears as part of the general formula of the quadratic equation or the formula of Bhaskara. We'll see this in a moment. Just take a look at this. If you have the quadratic formula, that means that just knowing the values of A, B, and C, you can manipulate those values and directly obtain the solutions to the equation without doing the factorization, for example. Some people find that factoring could be difficult. Some people use other methods such as completing squares, right? Completing the square trinomial, which we'll see in a moment in order to calculate how to obtain the vertex form. But here, for example, this is the Bhaskara formula. If you substitute the values of constants B, A, and C in this equation or in this formula, you get the two solutions. Here, notice that when you substitute here A, B, and C, you are considering this precise order. So here we would say A equals 1, B equals -4, and C equals -21. So these are the values to be substituted here. You can see it's already been done. But notice something. There is this expression -b plus or minus the square root of something over 2 times A. The double sign here means that we actually can obtain two different values for x. But what about the radicand of this expression? B squared minus 4 times A times C is what is called the discriminant. You understand something important here, okay? If the value of B squared minus 4A times C is a positive value, then the square root exists. And because of this, you will be able to obtain two real numbers as solutions of the equation. What happens when this expression B squared minus 4A times C is positive? Okay, there are two solutions. But if this expression equals 0 exactly, then that means that the root gets eliminated here. And if this expression B squared minus 4A times C is equal to 0, then the solution for x would be simply -b over 2a, right? That's it. Only one solution. Okay, I don't know what's going on. All right. It's just a matter of refreshing slides. Okay, people, take a look at this. What happens if B squared minus 4AC, the radicand, is negative? We know that we cannot calculate the square root of a negative number. So what does that mean? If there is a square root of a negative number, that is an imaginary number or complex number, okay? That means that the solutions exist, but not in the domain of real numbers. So this is what we're trying to say here. Okay, these three cases. The expression B squared minus 4AC, the discriminant, has three cases. What does that mean graphically? When there is two solutions, that means that the parabola cuts the horizontal axis in 2 points. When there is just one solution, it means the parabola is tangent to the x-axis in the vertex. But when there are no real solutions, when the discriminant is negative, that means that the parabola doesn't cut. the horizontal axis, okay? Like this. I think there is a question. Sorry, I didn't see. Fabiana, you want to make a question?
Yes, can you explain again, please, the spell formula, please?
Yes. The formula for the quadratic equation makes use of the constant values A, B, and C in the equation. And if you combine the values using the formula here, negative B, that is the inverse of B in sign, plus or minus the square root of B squared minus 4 times A times C divided by 2A, this yields two possible values for X, which are exactly the roots of the equation. Okay? For example, here, negative 4 multiplied by a minus sign, that is positive 4, this part. B squared is negative 4 squared minus 4 times A is 1, and C is negative 21, so this is 4 times A times C. Okay, this negative times this negative is positive, so you have 84 plus 16. This is 100. So the whole expression is reduced to 4 plus or minus the square root of 10 over 2. In other words, 4 plus or minus 10 over 2, which is 4 plus 10 over 2, that equals 7. And if it is 4 minus 10 over 2, that yields actually negative 3.
And how we know that, for example, the value of A, B in the first part?
How do we know the values of A and B? Are these values here? The coefficient of this term, that is A. The coefficient of this term, that is B. The coefficient here is C.
Oh, yeah. Okay.
Okay.
Thank you.
All right. So let's continue. Another example. If we have this quadratic equation, negative x squared plus 6x minus 10, what are the roots? Well, in this case, if we calculate the discriminant, that is this expression with the values A equal negative 1, B equals 6, and C equals negative 10, B squared minus 4 times A times C yields a negative value. This means that there are no real roots or solutions. And the fact that the coefficient of the quadratic term is negative, it means that it's an inverted parabola, a parabola upside down, with the arms of the parabola opening down infinitely. But the fact that there are no roots or solutions, it means that the parabola itself doesn't touch the x-axis, doesn't intersect it at all. Okay, so it's something like this. It's like here there is no intersect or no roots. Actually, there are two solutions, but they are complex numbers, which we'll not deal with in this moment. In a further lesson, we'll talk about complex numbers. But now, something interesting is, no matter that we don't know the actual solutions to this because there are no real numbers as solutions, we can still be certain that the formula for the sum and the product are accurate. The two imaginary numbers that are the solutions will have a sum of 6 and will have a product of 10. Yeah. They will not ask you, okay, what are the roots, the imaginary roots? No questions like that in the SAT. But they may ask you about the sum and the product, even though there are no actual real roots or solutions. Okay, be careful about that. What about the vertex form? Okay, for the vertex form, let's do this. You know that here you have y equals to negative x squared plus 6x minus 10. Let's just multiply everything by negative 1 for a moment, okay? In order to deal with this more easily. How to form the vertex form if we don't even know the vertex? If we don't know the vertex because we don't know the roots, we cannot calculate the vertex from the roots. So how do we do that? Take a look. What we're doing here is first focusing on this part and try to form a perfect square trinomial. okay? A trinomial that is the square of a binomial. I do this, x squared minus 2 times 3x. I give this form because I want to imitate this. Remember? I want to form this kind of trinomial. I know that I have the square of the first term. I have 2 times the first term times the second. So here I'm identifying. I have the first term, I have the second term, and I have twice. So I know that the second term must be 3. And because it is a negative here, it must be -3. So if I complete, what I need to complete the third term, the square of the second term, that it would be plus 3 squared. But if I'm adding 3 squared, I need to subtract 3 squared. Otherwise, I will be changing the whole expression. I add and subtract, and here plus 10. So what next? With this part, I can factor this out as the square of a binomial. This is the square of x minus 3. And this part here, I will operate with this part here. So 10 minus 9 is actually 1. So that's it. That's the form I was already looking for. Remember, a times x minus h squared plus k? That is the form, the vertex form of the equation. I already have something similar, but remember, this is equivalent to -y. So in order to obtain the true form, I multiply both sides by -1, and I obtain the form, the so-called vertex form of the equation. Okay, let's see one more example. This time, everyone will try to determine everything here. If I have this quadratic equation, what are the roots? Okay, there are several ways. You can use factorization. You can use the Bhaskara formula or the general formula, the quadratic formula, or any other method that you remember. Let's try to use factorization. So you have 2x squared plus 5x minus 3, and this equals 0. So what is the factorization? Let's try to find two factors, 2x plus something and x plus something, and two numbers such that multiplied, okay, in this cross form, yield this term 5x. And the two numbers here should be two factors of this number, -3. What about this, for example? 3 and -1. Why? Because 3 times 2x equals 6x, and x times -1 is -x. 6x plus -x will be exactly 5x. So I know that this factorization is correct. 2x minus 1 times x plus 3 equals 0. From these, the roots are the first root, x1 equals -3, from equating this to 0 and isolating x. From equating the second, 2x equals 1, x1 equals 1 over 2. So this is the second root. All right? That's one possibility. Okay, imagine that you don't have a clue how to factor. Okay, you can use the Bhaskara formula. You can say, okay, what is A, B, and C? This is A, this is B, this is C. So your formula is x equals minus b, that is -5, plus or minus the square root of b squared, that is 25, minus 4 times a times c, that's it, over 2 times a, 2 times 2. So what is this? You have a double negative, so it's a positive term. 4 times 2, 8, times 3, 24. 24 plus 25, 49. So this is -5 plus or minus the square root of 49, 7 over 4. So your two solutions, right? -5 plus 7 over 4, that is exactly 1/2. -5 minus 7 over 4, that is exactly -3. Your two solutions come from this expression. Okay, so you need to practice either factorization or the Bhaskara formula. Now, the sum and product of roots. Remember what is the sum? The sum is always negative b over a. So negative 5 over 2. Ready. What about the roots? Product of the roots. The product is always c over a. So what is c? Negative 3 over 2. And that's it. The vertex. Okay, the vertex is easy if we know the roots. We simply, average the two roots in order to have the vertex, remember, is h comma k. Okay, so finding h is negative 5 over 2, negative 3 over 2, and this over 2. So we have negative 8 over 2, which is negative 4 over 2, that is negative 2. What is k? K is what results from substituting negative 2 in the equation of the quadratic equation. So 2 times negative 2 squared plus 5 times negative 2 minus 3. What is this? What does it exactly yield? Okay, you have 4 times 2 is 8, and then you have 5 times negative 2, negative 10. So it's this. Negative 13 plus 8 is negative 5. So we have the vertex, that is to say, negative 2, negative 5. What is the vertex form? The vertex form, remember, you have y equals a times x minus h squared plus k. So just substitute the coordinates of the vertex and you're good. A is 2, so 2 times x minus 8 minus 2 equals plus 2. Square plus k. K equals negative 5. So we have negative 5, right? So we just here like this. And that would be it. The discriminant of this expression. What is the discriminant? Okay, the discriminant is b squared minus 4 times a times c. So the discriminant is 25. We already found it here, right? It was 49. Minus 4 times 2 times negative. So this is 40. Let's see another example. We have this quadratic equation, 4x squared minus 12x plus 9. What are the roots? Again, factorization could be good here. You have a term like, okay, take a look. 4x squared is the square of 2x. 12x is the same as negative 2 times 2x times 3. And what we have here, 9, is actually 3 squared. So clearly, this is a square trinomial. This is 2x minus 3 squared equal to 0. So the roots, actually here we say that the roots are 2 equal roots. So there is just one root because it is like, how to say, something like this. From here, x equals 3 over 2. So at this point, 3 over 2, if this is 1 and 2, this is 3 over 2. It's something like this. A parabola which is tangent to the x-axis exactly in this point, 3 over 2. So what are the roots? It's simply just that the two roots are the same, 3 over 2. What is the sum and product of the roots? Imagine that you have two identical roots with the same value. So what would be the sum? Okay, you could add them or simply use the formula. Sum equals negative b over a. In other words, 12 over 4 or 3. It's the same exactly if you add the two roots, right? 3/2 plus 3/2, two identical roots, you get just 3. And the product is C over A. So C is 9. 9 over 4 is the product. What is the vertex? Now that you have the two roots here, the good news is if you have a parabola tangent to the x-axis, that is one solution, the vertex is that point. So it would be 3/2, 0. And the vertex form of the equation, okay, is not difficult to see that this vertex form is actually like this, right? If you factor 4, you have 4x squared minus 3x, and you have plus 9. Okay, let's complete the trinomial, the square trinomial here. You have x squared minus 2 times 3/2 of x. And we need here the square of the second term, which would be 3 over 2. That is to say 9 over 4. Take away 9 over 4. This multiply by 4 and plus 9. Okay, this is y here, y. Okay, if we just take this part, this is 4 times x minus 3/2 squared. 4 times negative 9 over 4 is negative 9, which added with positive 9, you know, these two get canceled. So this is the form of the equation. This is the vertex form. Okay, now there are some more examples. Let's see some other questions that deal with the concepts of quadratic equations. In the xy plane, the parabola with equation y equal that expression intersects the line equals that expression at point A, B. What is the value of B? Remember what we said about when they tell you that two curves or two functions intersect? How do you solve that? If you have one function, f of x, another function, g of x, and they tell you that they intersect, how do you find the solution or the coordinates of the intersection or common point to the two curves? Simply solve this for x, and that's it. Okay, so here we can do the same. This can be seen as a system of equations. If y equals this, and at the same time y equals this, so what is the solution or the coordinates of the intersection point of these two curves? What results from equating this? These two. If you equate these two, what happens? Okay, you can see that x squared take away 8x plus 16 equals 0. And this is a square trinomial. If you train your eye a little bit, you can notice that this x squared minus 2 times 4x plus the square of 4, right? So this is x minus 4 squared. So from this, you know that the solution of this x equals 4. And so, since the solution is a comma b, that means that this is also the value of a. How do we find b? Okay, insert a here, right? And then calculate y. That's the easiest part. So b must be what happens when you substitute x for the solution, that is the value of a, 4, which is 3 times 4 minus 10. This equals 12 minus 10, 2. The solution is this, the value of b. Let's see another example. How many times does the graph of y equals negative x squared plus cx plus 3 intersect the line y equals 10 in the xy plane? Okay, again, remember what we said. If you have a function and they tell you, find the solution of, you know, intersecting this curve with a line y equals k. How do we do this? Okay, you simply solve this in this way. Say f of x equals k. solve for x, and you find exact points of the intersections. So if we equate these two, we would have negative x squared plus 6x plus 3 equals 10. The solution to this equation is the coordinate of the intersection points. So you have negative x squared plus 6x plus negative 7. We multiply this by negative 1. It would be like this. On both sides, multiply by negative 1, and you get x squared, take away 6x plus 7. So, something interesting. If you want to know how many times does this graph intersect, it's the same as knowing how many solutions does this have. But the number of solutions of this, you don't need actually to solve this. If you want, you can do it. But if you prefer to just know whether there is one or two solutions, find the, discriminant. How do we find the discriminant? Okay, b squared minus 4 times a times c. What do we have? Negative, actually positive 36, and here. So we have a positive number, right? By the way, it's the same if you take the original values in this equation. Don't get confused. Say, why the teacher has multiplied each side by 1, negative 1. It's the same if I take the original values. Here, A would be negative 1. Here, B would be 6. And here, C would be negative 7. If you calculate the discriminant on these values, it's exactly the same. It's 6 squared minus 4 times negative 1 times negative 7. So still you get 36, take away 28, okay? It's the same. I only multiply by negative 1 each side because it's more comfortable, okay, to calculate or try to solve anything like this, rather than manipulating the negative 1 before x squared. Okay, let's see a couple more examples before you take the quiz. Okay, this one. In the system of equations above, k is a constant. For which of the following values of k does the system of equations have no real solutions? This is a good question, so you can try. See if you can put together all the concepts, all the dots in this lesson. So what can we do here? Notice that if you change the form of this equation a little bit, it's this one, which means a horizontal line. So they're asking you what is the, the case in which this parabola, the equation below, and this horizontal line don't touch at all, don't intersect at all. That would be having no real solutions. So how do we do that? Okay, you can say this. How do we proceed in order to solve what are the intersection points? We normally say, okay, x squared minus 3x plus 1 equals k. So equating everything to 0 would be x squared minus 3x plus 1 minus k equals 0. If we want to make sure that this expression, this equation at the bottom, doesn't have any real solutions, what condition about the discriminant should we check? What should the discriminant be like in order not to exist any real solutions? Remember the three cases? Discriminant greater than 0, discriminant equal to 0, discriminant less than 0. Which one should we look for? Or which one should we expect in case there are no real solutions? Very good. This one. Thank you, Luciana. Okay, so if the discriminant is less than 0, let's try to calculate. What would be the discriminant in this? Remember, this is 1. Here we have B, and this would be our C. So B squared, -3 squared, take away 4 times A times C. And this should be less than 0. So we have 9. Here we have -4 times 1 minus K. Okay, open the parentheses, -4 plus 4K. And this yields what? 4K is less than this, -5. So if K is less than -5/4, which is -1.25, which of the values in the solutions actually corresponds? The only number less than this one is this. So this is the correct answer. All right. One more. A biologist uses the function P of n equals -100 n squared plus 1000 n to model the population of seagulls on a beach in year number n, where n between 1 and 10. Which of the following equivalent forms of P of n displays the maximum population of seagulls and the number of the year in which a population reaches that maximum as constants or coefficients? I think there is a typo problem here in the options. You can see that is A, P of n equals -4n. Everything in terms of n, options A and B, but option C introduces x. Here there is a typo, it should be n, okay? And the same goes here, it should be n. So how do we solve this? Take a look at something. It's interesting that if our P of n is our y, and our n is our x, so we have something like this. What about this coefficient? This coefficient represents that it's an inverted parabola. And in an inverted parabola, imagine that we have something like this, right? Okay, it doesn't really look as a parabola, but imagine that this is the vertex, okay? So it's an inverted parabola because of the coefficient of the quadratic term. And so the vertex in this parabola represents actually a maximum point, a maximum value for, in this case, P, okay? And this is N. So we are trying to find this maximum population or maximum value of P. Exactly the coordinate, vertical coordinate of the vertex. So how do we do that? If we put this in the, how to say, in the vertex form, we do this, right? First, you just factor the -100. Here, you would have this. (100) times -10n. So if you want to complete here the trinomial, you have n squared minus 2 times 5n. So you need to add here 25. Okay. And that's it. And we have to subtract here 25. But of course, 25 times this, which would be this number, right? -25 plus times negative would be here something like this. So, and here there is another term, no more terms. So this, if you factor, is simply n minus 5 squared. So this is the vertex form, -100, okay, plus 2500. That's it. So corresponds clearly, right? This form gives us the vertex, because remember, this is H, and this is always K, right? So the value of P max is the value of K. It would be 2,500. Actually, you could identify that, but exactly corresponds to option C. Okay, that's it. That's the last example for today's lesson. At the end of these slides, you can see like two review charts for all the concepts we've seen about quadratic equations, right? Okay, it's time not for a second quiz, but for the third quiz.